Today we are going to go over 8.5, the error bound. In chapter 8, part 2, there are two types of error bounds. Today, the error bound is only for alternating series. So before we go over the error bound, let's have a look. For alternating series, how do we determine if the series converges absolutely, conditionally, or diverge? So we have -1 to the n here. This is an alternating series. So first we put absolute value here. So absolute value -1 to the n over n. So the -1 is gone. This is a p series with n equals 1. So this series diverges. So the absolute value diverges. We have to see if the original series converges. So for the original series, it's an alternating series. Three conditions: an positive. Second, limit n go to infinity, 1 over n equals 0. 3, an plus 1 is less than 1 over n. So three conditions satisfied. So the series does converge. So original series converges and absolute value diverges, so we call it converge conditionally. So similarly, if we look at this series, the only difference is the power n plus 1 and the denominator. It's very similar to the first one. And this series, of course, will converge conditionally too. So both the original series converges. So for alternating series, even we know it converges, sometimes it's very difficult to calculate the real sum. So we might need to approximate the sum of the alternating series. In this case, when we approximate, there will be an error. So the alternating series error bound and the remainder theorem right here. Let's go over this together. So the condition here, if an alternating series is convergent, you have to make sure it converges. Only when it converges, we can approximate the sum. Then the absolute value of the remainder, or we call the error of the approximating the sum using the first n terms s of n, is less than or equal to the absolute value of the first neglected terms, an plus 1. So it's a little bit long, this sentence. Let's have a look at this equation. So this s is the real sum. And this s of n is the sum of first n terms. So the difference, if we use the first n term to approximate the real sum, the difference between these two is what we call the remainder. And the remainder is less or equal than the next given term, an plus 1. This is what does this whole sentence mean. If a series diverges, the sum doesn't even exist, so we don't apply this theorem. We cannot approximate the series. So generally speaking, s of n equals a1 plus a2 plus a3, the sum of the first n terms. And s minus s of n, which is the remainder, is less or equal than the next given term, the absolute value of the next given term, because sometimes it's positive, sometimes it's negative. So if we solve this inequality, s minus s of n is bigger than negative and smaller than the positive. So from here, we can approximate the real sum is your approximation minus the next term and s of n plus this term. So this gives us a very good idea. Even we cannot find the sum, however, use this formula, we can approximate the range of the real sum. S. Let me show you one example. But first of all, you have to make sure it converges. This is always the first step. You have to prove it converges. So if you look at example 1, given this alternating series, approximate the sum of the series using the first 3 terms. And what is the max error bound for this approximation? That means if we use the first 3 terms, what's the error between the approximation and the real sum? And what's the range of the actual sum lies between? So first, we have to show it converges. So 3 conditions: 1/n, an positive, limit of an goes to 0, and it's decreasing. So the series does converge. So next, we are going to see, if we use the first 3 terms, we are going to call it S of 3, A1 plus A2 plus A of 3. We plug 1, 2, 3 in, so it's -1/1 plus -1 squared over 2 plus -1 cubed over 3. Give us -1 plus 1/2 minus 1/3, -5/6. This is the sum of the first 3 terms. However, if we just approximate the real sum using this number, there will be an error, and the error will be given by the next term, which is A4. Don't forget absolute value. And A of 4 is given by -1 to the 4 over 4, which is 1/4. So this means if we use the first 3 terms, the maximum error will be 1/4. So from here, we can solve this inequality. 1/4. So the real sum will be between -5/6 minus 1/4 and -5/6 plus 1/4. So it's -13/12 and -7/12. So even we cannot find the real sum, however, we can approximate the interval. We have a better idea where the real sum will be between those 2 numbers. Okay, everybody, you can try the second problem and compare your answers with mine. This is the answer for number 2. Please have a look.